Hi guys, welcome to MetaMind. How are you all doing? Finally the NEET 2023 is done 2 days back. A big relief for all of you must be. Hope all of you have done extremely well. Okay. So in our continuation to the solutions, here is our analysis as well as solution of the physics portion of that paper. For that we have taken the F2 booklet. We could find out the F2 booklet. So from that F2 booklet, we will be giving you all the solutions of the physics section first, following by the chemistry and biology respectively. This session we are going to take up the physics one. So we will take up all the solutions of all the questions of F2 booklet. Okay. At the same time, in the end, I will try to give you the analysis with respect to the trend this year, what has been asked, and what it is right now compared to the previous year, because most of the students have echoed that physics this year has come tougher compared to previous, or not tougher in the sense it has come out of the way compared to what it used to be the earlier years or last 4 or 5 years trend. So we'll try to see that analysis also in the end of this solution section. Yeah, it is different in terms of coverage as far as the previous 5 years trend is concerned, that we can see it out. But in my analysis, the questions this year have come rather much more straightforward, direct on the formula compared to what it used to be the earlier years. So when I go as per my analysis, I find the papers are a little bit easier compared to the earlier years. But as for the students, what happens is when we are trying to go for a trend, we know, okay, this particular chapter is much more coverage. Thermodynamics, for example, used to be a very much stress point earlier, but now this year it has got very least coverage, all that. So we'll see that. Let's go through first the questions one by one and see how you relate it out with my statement where I say the questions were straightforward in the formula. They were more towards the basic concept rather than digging deep inside. In fact, this year the such questions which were going to take some kind of time was also much lesser, and it should have rather helped in the time management. That's what is my assessments. So let's start with that. As I told you, we have taken F2 booklet. So we are trying to do the questions. You can straight find these questions in F2 booklet if you have. But anyway, all other, whether it is F1 to F6 or Q1 to Q6 or R1 to R6 or E1 to E6, questions are same, only 1 or 2 questions here and there are changed. But otherwise, they will be same. So let's start our solutions one by one. Okay. And then we'll see the analysis also in the end. Okay. The very first one, straight on the Gauss law. Okay. E dot ds is 0. E dot ds means there is no net charge inside. Okay, no net charge inside, otherwise the charge is there inside, then there has to be a net flux outside. Okay, because that's what the Gauss law says. So there is no net flux inside. It means the number of flux lines entering the surface must be equal to the number of flux lines leaving it. So correct answer should be 4. Next, straight fundamental theory questions. Right here also, the error in measurement which arise due to unpredictable fluctuations in temperature and voltage supply are. What is the reason told? Unpredictable fluctuations. Unpredictable fluctuations. Unpredictable is the other word of random. Okay. So when you see it out, this should be 3. Okay. That itself says if it's a predictable fluctuation, unpredictable like linear temperature coefficient is known to you, then it was going to be the systematic or instrumental, but that is not the case. It is very clearly writing unpredictable fluctuation. So it is going to be random. Next, a football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. The force that acts on the player while turning is. Okay, fine. So the force here will be basically there is one direction of momentum and suddenly it is changing into another direction. So the force is nothing but rate of change of momentum. What we have to find it out is just draw the diagram north, south, east, west, give it I, give it J. Okay. So player is moving, say the velocity is U, mass is M. So what will be delta P? Delta P will be P final minus P initial. So how much is that P? Now first it is moving southward. So it is going like this, right? And then it is suddenly player is moving southward and suddenly turns eastward. So while going it goes eastward. So when it is going southward, say, okay, for our purpose we can take this as J. So we can say minus of MUJ. If I give this as J, this is minus MUJ, and eastward is MU times I. So your delta P will be MU times I minus mu times minus mu times j. So this is mu times I plus j, right? I plus j means south and east. I plus j is there, so this is I and this is j. This is how it is. Okay. Mu times I minus minus plus mu times j. So mu times I plus j. Am I right or wrong? Anyway, this is the magnitude, and when you say delta p by delta t is mu by delta t I plus j. So direction is I plus j. I was eastward, j was northwards. So north is direction. Okay. This. Fine. Next. A metal wire has 0.4 plus minus 0.02 mass in grams, radius in mm and length in this. The maximum possible percentage error in terms of the density. Why? So density is mass by volume, right? Now volume in terms of radius, right? No? So radius is metal wire has mass this, radius this and length this. So it is a metal wire means like this. So your area will be pi r square and length is L. So total volume will be pi r square L, right? Multiplied by density. Metal wire has this m length, the maximum possible in the percentage of density. So mass will be, so density will be mass by volume. So mass by volume. Okay. Volume is pi r square L multiplied by density D. Okay. Now your mass has gotten percentage error. So what will be delta error? Delta error will be delta of ME mass error plus r square. So 2 times delta of radius error, and then there is length also plus L is only power m. So delta of L error. Okay, this is how it is going to be there. This is what is the formula coming. Mass is 1 time, R is a square and L is 1 time. So this is 1 time, this is 2 times and this is 1. So your delta E will become, now delta M. Delta M is what? 0.002 by 0.4 into 100% plus, because the answer is in percent. Then similarly 2 times 0.001 by 0.3 into 100 plus, how much is this? Length. Length is 0.02 by 5 into 100. This is what will give you the answer in percent. So it will be 0.2 by 0.4 plus, again it will become 0.2 by 0.3, and this will become 2 by 5. Okay. So this is giving you 0.5, this is giving you 0.67, and this is giving you 0.4. Okay. So 5 plus 4, 9, 0.7, 707. So the 1.57. Yeah, this is the one. Correct answer is 1.57. 1.57 approximated to 1 digit is 1.6%. So your error is 1.6%. Next, the net magnetic flux through any closed surface. You know, like in a charge you can have a single charge of a positive or minus, but for monopoles does not exist. Means a single north pole or single south pole cannot happen. So that's why net through any closed surface, okay, has to be 0. Why? Because if monopole is there, there can be net outward or net inward, but you cannot have monopole, you only have a dipole inside, so net flux is bound to be 0 in a closed surface. Next, in a series LCR circuit, the inductance L is 10 millihenry, C is 1 microfarad, resistance is 100 ohm, the frequency at which the resonance occurs. Frequency at which resonance occurs. So resonance, this has got no meaning. Okay, at resonance frequency F is 1 by 2 pi under root LC. Okay, it comes from omega is equal to 1 by root LC. Omega is 2 pi F. Okay, so you put in over here 1 by 2 pi under root of L is 10 millihenry. So 10 into 10 raised to minus 3. And C is 1 microfarad. 1 into 10 raised to minus 6. Right? So minus 3 minus 6 is minus 9 minus 8. Right? Minus 3 minus 6 is minus 9. 1 minus 8. So 1 by 2 pi 10 raised to minus 4. Right? That is 10 raised to 4 by 2 pi. This is 10 raised to 4 into 7 by 2 into 22. Okay? If I take it roughly to 3 point something, and then this will be solving it out, right? So 10 raised to 4, if you take 100, 10 raised to 2 into 100 into 7 by 2 into 22. So you can roughly say 5, 35, 17 point, nothing less than 17.5, 17, yeah, 1.59, okay, not radian. You are supposed to talk in terms of kilohertz, right? So it is coming as 1.75 10 raised to, yeah, kilohertz, 1.59 kilohertz. That is how it will come, okay, because the answer is roughly coming as, roughly when I say 5 7 35, 17.5 into 10 raised to 2, 1.75 10 raised to 3, so 1.59 kilohertz. The answer will be 1.59 kilohertz. I am not going, I mean, this is how the approach has to be there. We don't have to calculate exactly. We see from here and then we come back. So the answer is going to be 1.59 kilohertz. Go to the next. Yeah, the magnitude and direction of the current in the following circuit is, fine, straightforward, Kirchhoff's law from A to B. So A to B, when we go it out in this whole circuit, let's say we are going from A to B. So when I am going from A to B, you have got resistance as this, the voltage. So current I will be 10 minus 5, okay, divide by what is the total number of resistances? 2 plus 1 plus 7. Right, so 10 minus 5 is 5, 10 minus 5, why? Because 10 and 5 are opposite directions, so this is giving plus while this is opposing it out, okay. So 10 minus 5 divided by 2 plus 7 plus 1 is 10, 5 by 10 is 0.5 amps from A to B, 0.5 amps from A to B, answer is A. 9. Equivalent resistance of the system, capacitance. Are you finding it out? It's coming straight on the formula. You can see it out. I am writing it out one program. I am question, seeing the formula, putting it out, and that is how it is. That's what I told you earlier. Then the questions were rather straightforward on the formula rather than thinking too much inside it. So you go over here. This two is parallel combination, right? So this two is first of all parallel combination. 3 mu, 3 mu. So C equivalent will be C1 plus C2. That is 6, and then this 3 and this is also 3, and this is now 6. So C equivalent will be C1 C2 by C1 plus C2, that is 3 into 6 by 3 plus 6, 18 by 9, 2 microfarad. Answer is 2 microfarad this. Okay, straight. Next. The magnetic energy is stored in an inductor of inductance this, current 2 amps. The energy stored in an inductor is half Li square. Okay. So this is half L is 4 into 10 raised to minus 6 and I is 2 square. So that is 1 by 2, 4 into 10 raised to minus 6. 8 microjoule. 8 microjoule. 9th. Go to 10th. The Venturi tube, it's coming from properties of fluids. Okay. Bernoulli, principle of parallel axis is optics. Principle of perpendicular axis is parallel and perpendicular axis is from moment of inertia. Huygens principle is optics. This is only the Bernoulli principle forming Venturi tube is there. So answer will be 1. Next. The half-life of a radioactive substance is 20 minutes. Okay. In how much time the activity of substance drops to 1 by 16. So what he is talking is, we have a formula, activity A is initial activity A0 by 2 raised to n. Okay. This is the formula, or you can say A by A0 is 1 by 2 raised to n. Right. So what is being told over here? A by A0 is 1 by 16. It drops to 1 by 16. So 1 by 16 is 1 by 2 raised to 4. This implies n is equal to 4, and hence time will be n times t of half-life, right? So 4 into what is the half-life? 20 minutes, right? So that is 80 minutes. Answer should be 80 minutes. Hello. Okay, go next. The ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the ratio of thin. Okay, so you have to find out radius of gyration for a solid sphere and hollow sphere of the same mass. The mass is same. For the solid sphere, your radius of gyration r solid is under root of 2 by 5 of the radius. Okay, and hollow sphere r hollow is under root of 2 by 3 of r. This is how it is. So if you take which ratio? Solid to rs by rh, we are supposed to take it out. So under root of 2 by 5 times r by under root of 2 by 3 times r. Okay, so that should come out to under root of 2 by 5 into under root of 3 by 2 by 5, 2 by 3 by 2. So rs by rh is under root of 3 by 5. Okay? Under root of 3 by 5. Sorry. So this is not, there is none of this. None of these. Answer is actually under root of 3 by 5, not 3 by 5. Answers are not right, okay? Answer is root 3 by 5, not 3 by 5. Yeah, this is a wrong answer. None of them. Go to next. A 12 volt 60 watt lamp is connected to a secondary of a step down transformer. So you have a transformer. Transformer has got whose primary is connected to 220 volt AC. So here you are giving 220 volt AC, and secondary side you have connected a lamp. This is a lamp which is connected to secondary of 12 volt 60 watt. So your lamp is 12 volt 60 watt and primary is having 220 volt AC, step down transformer. Assuming the transformer is ideal. Okay, so transformer is ideal means, what is the meaning of ideal? Ideal means no losses. No losses means power input is equal to power output. For ideal transformer, P in is equal to P out. Now what is P out? 60 watt. Okay, so P in also will be 60 watt. Am I right or wrong? So now what you can say is P out also will be 60 watt. Therefore P in is equal to 60 watt. Now what is P in? You have got voltage as 220 volt and you don't know what is the primary current. I in must be 60. So this implies I primary side is 60 by 220. We can take this because transformer is ideal. Otherwise we have to take losses. 2, 11, 3. So it's 3 by 11. 0.27, less than 0.3, right? So 0.27. Okay, next. The temperature of a gas is minus 50 degrees centigrade. To what temperature the gas should be heated so that the RMS speed is increased by 3 times? Straightforward kinetic theory of gases. Root mean square speed, V RMS is under root 3 RT by M. So when you say V RMS is proportional to under root of T, or you can say V1 by V2 is under root of T1 by T2. Okay, now go back and put in. So what it will be? What is your T1? T1 is minus 50. So T1 is 273 minus 50. How much is that? 223. So T1 is 223. Now gas should be, RMS speed is increased by 3 times. There is a trick over here. It is increased by 3 times. So if V1 by V, then V2 is equal to 3 times V plus V. Total is 4V. Why it is increased by 3 times? So V plus 3V. So V2 will be 4V. So it means V1 by V2 is 1 by 4 is equal to under root of T1 by T2. Right? This implies 1 by 16 is T1 by T2, implies that T2 is 16 times T1. 16 times, how much was that? 223. Right? Three, 5, 6, 8 minus 273. Okay, so 3295 degrees centigrade. Okay, got? Next. A bullet is fired from a gun at a speed of 280 meter per second in the direction 30 degree, theta is 30 degree, u is 280 meter per second, above the horizontal, g is 9.8, height attained, maximum height h you are supposed to find it out, so h is u square sine square theta by 2g, okay, put in, so h is u, that is h is 280 square sine 30 square by 2g, 2 into 9.8. Put in 280 sine 30, he has written 0.5, 0.5 square by 2 into 9.8. Okay. So that is 280, 0.5, 0.5 by 2 into 9.8. Okay. Right. So 28, 2.8, 2.8 by 5. Okay. So this will become 28 into 28.5 into 25 by 2 into 9.8, say 10, 20, 20 by 25, okay. Uh, 0.8 into 10, roughly around, yeah, this is the answer, 1000, okay. The amount of energy required to form a soap bubble of radius 2 cm from a soap solution is nearly, surface tension is given to you, surface tension S is 0.03, radius of the bubble is given to you as 2 cm, and what is the energy? So how is the energy defined? Energy defined is nothing but increase in the surface area multiplied by the surface tension. How is the surface tension defined? Energy per unit surface area, okay, that is how the surface tension is defined. So energy is surface tension multiplied by increase in energy. So your energy is S into delta A, but this is a soap bubble, so multiplied by 2 because there are 2 layers, 2 areas, okay. So put it now straightforward, S is 0.03 AH, soap bubble, so 4 pi r square, right, 4 pi into r, 2 raised to minus 2 whole square into 2 times, right, no? So this is 0.03 into 422 by 7 into 4 into 10 raised to minus 4, okay, 0.034 pi 2 into 10 raised to minus 2 whole square into 2, okay. So this comes out to be 0.034 pi 16, 22 by 7, 22 by 7, 4, 10 raised to minus 4 into 2, right? So this is roughly 339, 9 2 is 18, 4 is 72, okay, 339, 9, 36, 72 into 16 into 10, 0.03 into 10 raised to minus 4, okay, 27, 22 into 16, okay. So, 1152 into 3 into 3, 11, 3 is 33, 34, 10 raised to 3.4 somewhere, yeah, this is the one, 2 is the answer, okay. Minus 4 remains as it is, this is how it will come. Yeah, we have to calculate it out and try seeing it out over there, which one is the closest coming out. It is only confusion around the power, nothing else. So it is coming as 3. Next, in hydrogen spectrum, the shortest wavelength is the Balmer series. The shortest wavelength in the bracket series is there. So for Balmer series, n is equal to 2, and for bracket series, n is equal to 4, right? And you have r into 1 by n2 square minus 1 by n1 square. This is the equation of 1 by lambda, right? So what is being given is 1 by lambda 1, that is lambda is equal to r times 1 by 2 square minus 1 by infinity square. So this implies lambda is equal to r, okay, so for bracket series 1 by lambda 1 is equal to 1 by lambda Balmer is equal to r by 4, that is 1, okay, and which is given to you as lambda, okay, right. So for bracket Balmer you have got, then for bracket 1 by lambda 2 is r 1 by 4 square minus 1 by infinity square, that will come as r by 16, right. So lambda 2 by lambda 1, that is lambda bracket by lambda Balmer is coming out to be 4, and this is given as lambda, so that should be 4 times lambda. Answer should be 4 times lambda. This one 17. Next, let a wire be suspended from the ceiling, rigid support, and stretched by a weight W, okay, attached at its free end. The longitudinal stretch at A, okay, fine. Here is a trick. The trick is weight given. So this whole thing is weight. The force is W, okay, and this wire has cross section area A. So longitudinal stress is defined as force, reacting force per unit area. It's not only force, reacting force per unit area. Weight is on W, so it will have a stress W in this direction, and this is acting on the cross sectional area A, so your stress will be W by A, this one, 18. Next, angular acceleration of a body moving along the circumference of a circle is along the radius towards the center, along the tangent towards its position, along the axis of rotation. Angular acceleration is always towards its axis of all. If it is originating like this, it's like this, it's downward. So it is always along the axis of rotation. 3. Okay. Next, two bodies of mass m and 9m are placed at a distance r. Two bodies of mass m and 9m are placed at a distance r. The gravitational potential on the line joining the bodies where the gravitational field equals 0 Okay, so you have gravitational field equaling 0 somewhere else. Say this is the point where field is 0 and it is distance x from the body, right, from M. So what you can say, E1 is equal to E2. Now gravitational force is Gm by R square, right or wrong? So we'll write for this, Gm is small m by R is x square, right, is equal to G into 9m by how much distance they have? They are separated at a distance R. So R minus x square. G gone, m gone. So you can say R minus x square by x square is 9. R minus x square by x square is equal to 9. This implies R minus x by x is 3 or R minus x is 3x. This implies 4x is equal to R. This implies x is R by 4. So now this distance is R by 4 and this is 3R by 4. Okay, right? So now we calculate the potential. So potential formula is V is equal to G times M by R. Right or wrong? Okay. So we go back and put in M and G M, right now. So here the gravitational potential will be this side and then this side. You find it out. Okay. So what will happen? Where the field is 0, what is the gravitational potential over there? So G into M by R is R by 4. Okay. And for the other one, it is going to be, how much is this? G into 9M by R minus R by 4. So that is 3R by 4. Okay. So we have got now x as M 9M 3R by 4 and R by 4. Okay. So it will be G into M by R by 4 and G into M by 3R by 4. Okay. No. Gravitational potential is 0. Gravitational potential, where the gravitational field is equal to 0, find the gravitational potential on the line joining. Yeah, so potential is this. That will become, how much it will be? Z into M. So it will be 4gm by R plus, all will be minus of course, by 4g into 9m by 3R. Take it out. 4gm by R common, 1 minus 9 by 3. Minus 12, minus 12, minus 12. This one. This is what is coming out. Okay. Yeah, minus 12 by R. That's what it's coming out. Okay. Let's see. Next. A full wave rectifier circuit consists of two PN junction diodes, one center tap rectifier, a center tap transformer, capacitor and a load resistance. Okay. Which of these components remove the AC ripple? Okay, fine. AC ripple means rectified DC. Rectified DC is like this, full wave rectifier, and you want to smoothen it out. For smoothing it out, we put a capacitor. This is called as AC ripple. In AC ripple, we have to remove out the ripples, then we put capacitor. So which components remove AC ripple? Capacitor removes the AC ripple. Right? A vehicle travels half the distance with the speed v and remaining half distance with the speed 2v. Its average speed each. Okay. So half of the distance. So it is s by 2, s by 2, s by 2 with v and s by 2 with 2v. So what is the time taken? T equal to t1 plus t2. T1 is s by 2 by v and t2 is s by 2 by 2v. So that is s by 2v plus s by 4v, and therefore velocity, average velocity is S by 2V plus S by 4V. That is 4V into S by 2S plus S. So it becomes S to 3S, S 4 by 3. Answer is 4B by 3. So whichever way you do it out, your average velocity is going to be 4B by 3. Okay. Next. A Carnot engine has an efficiency. Oh, finally we have a problem from thermodynamics. A Carnot engine has an efficiency of 50% when the source is at temperature 327 degree T1. The temperature of the sink is, very good, fantastic. So Carnot engine efficiency is 1 minus T2 by T1 or T sink by T source. Okay, got my point? So you have got 327. So your T1 will become 327 plus 273, it's 600. What is the efficiency? 50%. So 50 by 100 is 1 minus T2 by T1. This implies T2 by T1 is 1 minus 1 by 2 is 1 by 2. Therefore, T2 is T1 by 2. What is the T1? 600. So 600 by 2 is 300 Kelvin. But you are in degree centigrade. This implies sink temperature T2 is 300 minus 273 is 27 degree centigrade. So answer is this. Next. In a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at a frequency and amplitude. So you have given F is 2.0 10 raised to 10 hertz, that's fine. E is given to you, or E0 is given to you as 48 volt per meter. Okay, amplitude of oscillating magnetic field. Okay, so actually F has got no meaning over here. We have got E0 by B0 is, E0 is amplitude of electric waves and B0 is amplitude of magnetic waves, is equal to C, speed of light. So we have to use this formula, and hence B0 is E0 by C. Okay, that is E0. Now E0 is 48 volts per meter divided by 3 into 10 raised to 8. Right now, so put in 16 into 10 raised to minus 8 Weber Tesla. Yeah, minus 9. 16 is not given to you, so you can write 1.6 into 10 raised to minus 7. Yeah, this is the one. Okay, 1.6 into 10 raised to minus 7. Be careful, all are looking 1.6. So you'll be careful about power. Yeah, 10 raised to minus 7. 24, 25. The ratio of frequencies of fundamental harmonics produced by an open pipe to that of closed pipe having the same length. Okay, so you have got a open pipe, so you get a antinode at both ends, right? So it gets like this and it gets like this. So you have got lambda by 2 is equal to L, so lambda is equal to 2L, and therefore F open will be V by 2L. If it is closed pipe, it will be like this. So this is lambda by 4, hence lambda by 4 is equal to L. This implies lambda by 4L, and F closed is V by 4L. Okay, and therefore what ratio you want? Open pipe to closed pipe. So F open by F closed is V by 2L by V by 4L. So that is V by 2L into 4L by V is 2:1. Right? 2:1. This is the one. Okay, now go from the next equation. For Young's double slit experiment, two statements are given below. Okay, fine. Screen is moved away from the plane of the slit. Angular separation of the fringe remains constant. Statement 2, the monochromatic source is replaced by another monochromatic source of larger wavelength. Angular separation of the fringe okay, so angular separation is given is lambda by d. Okay, if you see over here, what is the, so if you see in that, capital D is not coming in picture, this D is not coming in picture. Okay, so it is independent. It means the screen is moved away, angular separation remains same. Okay, this is the slit width. So it is dependent upon slit width, not on the distance. That's why remains independent is correct. Monochromatic source is replaced by another monochromatic source. The angular monochromatic source is replaced by another monochromatic source of larger wavelength. If it's a larger wavelength, then fringe width, angular separation increases, not decreases, because it's proportional to lambda. Okay, fringe width is proportional to lambda by d. So angular, if in lambda is increased, then angular separation should increase. Okay, it is giving decreases, so wrong. It means first is right, second is wrong. Statement 1 and statement 2 are false. No, statement 1 is true, statement B is 2 is false. This is the answer. Okay, because it actually increases, not decreases. Okay, next. A work function cesium, potassium, sodium 2.14, 2.30, 2.75 respectively. If incident electromagnetic radiation has an incident energy of, we have taken it out, no? Yeah, okay, fine. If incident electromagnetic radiation has an incident energy of 2.2 eV, what is the work function? Energy is 2.2 eV, and what is the work function? So 2.14, work function of cesium, potassium and sodium is 2.14 eV, 2.3 eV and 2.75 eV. Okay, but incident electromagnetic radiation has an incident energy of just 2.2 eV. So what is important is your incident energy should be greater than the work function. So 2.14 is less than 2.2, but 2.3 is greater than 2.2, 2.75 is greater than 2.2, so this two will not, only this will do. 2.14. 2.14 corresponds to cesium. Okay, the work function of cesium is 2.14, so only cesium. Which of these photosensitive surfaces may emit photoelectrons? Emit photoelectrons means 2.14. 2.14 is cesium, so this. Okay, next. The minimum wavelength of X-ray produced by an electron accelerated through a potential difference of V volts is proportional to, okay, so EV is Hc by lambda minimum. This implies lambda minimum is Hc by EV. Now Planck's constant this, so lambda minimum is proportional to 1 by V. 1 by V. 28. Okay, next. Resistance of a carbon film resistor determines from color code is 22,0005%. The color band of third band must be, okay. So if a resistance is there, first band, second band, third band and fourth band, these two are values. This is the 10 raised to power, right, index, and this is the percentage. So we are asking about third band. So what is given is 2, 2, first is 2, second is 2, third is 10 raised to 3. Okay, third band is being asked. So 10 raised to 3, and now you write B. Roy of Great Britain. So B is 0, 1, 2, 3. Black, brown, red, orange. So third band should be orange. This one. Okay, next. An AC source is connected to a capacitor C. Due to decrease in its operating frequency, what will happen? Displacement current, capacitive reactance. Okay, capacitance only, displacement current will be there. Now Xc is 1 by omega C. That is 1 by 2 pi Fc. So what is being told? Operating frequency decreased. So when F is decreased, Xc will increase. As Xc will increase, so current will be V by XC. So XC is increasing, so current will decrease and reactance will increase. So displacement current decreases, capacitive reactions, no, capacitive does not remain constant, capacitive reactions decreases, no, increases, displacement current increases, no, displacement current decreases. 2 is the answer. 30. Photovoltaic device can convert optical radiation into electricity. Photovoltaic devices can convert optical radiation into electricity. Yeah, that's true. Zener diode is designed to operate under reverse bias condition. Both are true actually. Photovoltaic devices are meant for converting the light to electricity, and Zener diode is always operated in the reverse bias breakdown condition. So both statements are true. Yeah, 4. Okay, next. An electric dipole is placed at an angle 30 degree, theta is 30 degree. Okay, electric field E is 2 into 10 raised to 5 Newton per coulomb. Okay, torque tau is equal to 4 Newton meter. Dipole strength, magnitude of charge on the dipole strength if the dipole length is 2. So first of all, what is the dipole moment? Then we will calculate the charge. Dipole moment tau is equal to P sin theta. P sin theta. P is dipole moment, right? Now we don't know dipole moment right now, so we will put it out. Torque is 4. 4 is equal to, we don't know P, but we know E. E is 2 into 10 raised to 5 sin theta sin 30, right? So 4 is equal to P 2 into 10 raised to 5 1 by 2. So P is equal to 4 into 10 raised to minus 5. Now P is equal to 2Q into L. Okay, the dipole length is 2 centimeter, so 2L is given to you is 2 centimeter. Now P is equal to Q into 2 centimeter, 2 into 10 raised to minus 2 you can say. Therefore Q will be P by 2 into 10 raised to minus 2. How much is P? 4 into 10 raised to minus 5 by 2 into 10 raised to minus 2, right? 2 into 10 raised to, yeah, 2 millicoulomb. This is the answer. Okay, next. A potential energy of a long spring when stretched by 2 centimeter is U. If the spring is stretched by 8 centimeter, the energy stored E is half kx square. If you know, energy stored in a spring is half kx square. So put in the value half k into x square, you have 8 square, right? No? So 1 by 2 into k into 8 square is 64, 32k, or you can say E1 by E2. E1 by E2 is x1 by x2 whole square. Okay, so E1 is given to you as U, E2 we do not know, x1 is 2 and x2 is 8 whole square. So E2 should be 16 times E1, 16U, yeah, 3. Okay. Light wave travels x, a distance x in time t1, distance x in time t1 in air and 10x in time t2 in another denser medium. What is the critical angle for the medium? Okay. So this is your denser medium and this is your rarer medium. Okay. this is your theta c, okay. So sine of theta c is 1 by mu, or you can say mu1 mu rarer by mu denser. This is how the formula is. Sine of theta c is mu rare by mu dense, okay. So theta c is ultimately sine inverse mu rarer by mu denser. This is how it is, okay. Now let's calculate mu. How do we calculate mu? Light travels a distance x in time t1 in air and 10x in time t2 in other medium. So basically, you know what is mu? Speed of light in air by speed of light in a medium, right? No? So your mu is anyway. So mu rare will become same distance it is traveling in time t1. So mu will be t1 times, right? No? It is taking t1 time, whatever distance it is taking with c. So you can say mu will be speed of light in, so it will become what? X into t1, right? No? Speed is x into t1. So what happens is here, mu is equal to speed in air or vacuum by speed in medium. This is how it comes, right? No? So let's say for first medium, it takes time t1 for traveling the same distance x, it is taking the time t1, and so compared to rarer to denser, are you getting my point? Same distance x in time t1. So what is the speed? X by t1, right? In medium 1, so v1 will be x by t1 and v2 will be 10x by t2, right? No? Now you have to, so when we say mu, and mu is given as c by v, okay. So we have to take is mu r by mu dense, that is c by vr by c by v dense. This implies mu r by mu d is vd by vr. Now vd is 10x by t2, 10x by t2 by x by t1. So it will be 10x by t2 into t1 by x, 10 t1 by t2 sine inverse 10 t1 by t2. This is the one, okay. Next, if the galvanometer G does not show any deflection in the circuit shown, the value of R is given by, okay, fine. So here what is being shown over here is this galvanometer, there is no current flowing, okay. Since there is no current flowing in this side, so this voltage is plus 2 volt. It means this also should be plus 2 volt. Only then there will not be any current flowing into this side. That was the only trick involved in this particular question, okay. So since there is no current flowing into this side, so this node must be 2 volt. In that case, the circuit becomes something like this, if you see it out, right? It becomes like, okay, this is 10 volt, this is 400 ohms, okay, and this is the resistance what we are supposed to find it out. Now this node is 2 volt, okay. Why? Because there is no current flowing into this side. So if you see, then therefore the drop across this 400 ohms, right? Therefore voltage drop across 400 ohm resistor will be how much? 10 volt minus 2 volt, that is 8 volt, right? So this is the 8 volt drop across this resistance, and let the current is I. So let I is current in the circuit, okay. This is the current I. Therefore V equal to I times R. So what is the V over here? 8 volts, right? So 8 is equal to I, and what is the R here? 400 ohms. This implies I will be 8 by 400. This is coming to 0.02 amps. Okay? Is this clear? 8 by 400 volts. 0.02 amps, and now this is the same current which is flowing through R also. Now drop across R is 2 volt. Okay, and current is 0.02 amps. Okay, so what is the voltage? V equal to again I times R. This implies R is equal to V by I. What is the V? 2 volts, and what is the I? 0.02. So that comes out to 100 ohm. Okay, so the R value should be 100 ohm. This is the answer. Okay, next. The resistance of a platinum wire at 0 degree centigrade is 2 ohms and 6.2 ohm at 80 degree centigrade. The temperature coefficient of resistance, okay, straightforward. RT is R0 1 plus alpha delta T. R0 is resistance at 0 degree centigrade. R0 is given to you as 2 ohm. R80 is given to you as 6.8 ohms. And delta is 80 minus 0, that is 80. So you put in over here. 6.8 is equal to 2 into 1 plus alpha into 80. So 6.8 by 2 is equal to 1 plus alpha into 80, 3.4, right? 3.4 minus 1 is alpha into 80. This implies alpha is 2.4 by 80. Right? So 10 raised to minus 2, 3 into 10 raised to minus 2, 0.03. 3 into 10 raised to minus 2. Right? No? 8. Okay? 2.4, 24 into 10 raised to minus 1 by 10 raised to minus 1. Tick. 3 into 10 raised to minus 2, 36. 37. A satellite is orbiting just above the surface of the earth with period t. So this is the radius of the earth and satellite is orbiting here only. So you can say R is approximately equal to R. That's what it's trying to tell you. D is the density of the earth, G is the fine. So time period t is given as 2 pi under root of R cube by Gm. This is the formula. So now m can be given as 4 by 3 pi r cube into d. Is this clear? So I'll put in our value 2 pi under root of r cube by g, and this is 4 by 3 pi r cube into d. So 3 goes over here, 2 pi under root of 3r cube by g into 4 pi into d into r cube. R cube gone. Now 4 pi, so put 1 pi here, then this will become pi square. 4 pi square is 2 pi. So that will become 2 pi by 2 pi under root of 3 pi by g d. Okay, so it's gone. So what we say, t is equal to under root of 3 pi by g d. Okay, 3 pi by g d out of the square, therefore t square is 3 pi by g d. So it should be t square 1. 37 1. Go next. In an xt graph of a particle performing simple harmonic motion is shown in the figure. the acceleration of the particle at t equal to 2 seconds. T equal to 2 seconds, you are supposed to get an acceleration. So for acceleration, if you see the particle amplitude A is equal to maximum amplitude is 1, right? Now if you see, it is like this, and this is your maximum 1. So amplitude is equal to 1. Now time period is 0, 2, 4, 6, 8. Total time period t is equal to 8. Therefore omega is 2 pi by t, that is 2 pi by 8. It is pi by 4. So equation x is equal to a sine omega t. Okay. So v is a omega cos omega t, and acceleration is a omega square sine omega t with a minus, right? So now put in a is your 1, omega square is pi by 4 square sine pi by 4 t. Okay, so this is pi square by 16 minus, of course, sine pi by 4 t. Now what is he asking? At t equal to 2 seconds. So you got a as we have got as pi square by 16 sine pi by 4 t. Therefore at t equal to 2, put in over here. So it will be pi square by 16 sine pi by 4 into 2. That becomes sine pi by 2 is 1. So value is pi square by 16. The value will be pi square by 16. The answer will be pi square by 16. Next, a radius of innermost orbits of hydrogen is 5.3. Innermost is this. First, what is the radius of third allowed? So we have got Rn is n square by z. Okay, so R1 by R2 is n1 by n2 whole square. Okay, first orbit is 5.3 into 10 raised to minus 11 by R2 is 1 by 3 whole square. So R2 is 9, 5.3, 10 raised to minus 11. 47.7, 10 raised to minus 11, or you can say 4.77, yeah, here it is, 4.77 angstrom. Next, 10 resistors each of resistance R are connected in series to a battery of EMF E. So you have got 10 resistors connected in series. So R equivalent in series will be 10R and negligible. Then those are connected with parallel and equivalent again. So R equivalent in parallel will be R by 10. Okay. Current is increased n times. The value of n is, and battery is E. So I in series will be E by R equivalent of series. That will be E by 10R. Okay. And I in parallel will be E by R equivalent parallel. So that will be E by R by 10. So what are they asking? Parallel to I parallel by I serial is equal to N. That is equal to 10 E by R by E by 10R, right? Okay, so that is 10 E by R into 10 R by E. E gone, R gone, 100. So n is equal to 100, 40. A horizontal bridge is built across a river. There is a river here. Okay. Bridge. A student standing on the bridge throws a small ball vertically upward. Here u is 4 meter per second. The ball strikes the surface after 4 seconds. The total time is 4 seconds. Height of the bridge here, what is this height we are talking? Take g as 10. So it's very simple. Velocity u is equal to 4 meter per second. Acceleration a is minus 10 meter per second square. It is downward, it is upward. And we have to find out the distance s is equal to ut minus half at square it will become. So u is 4, t is 4. T taken total time of journey is 4 minus half into 10 into t square 4 square. Okay. 4. So that is 16 minus 5, 80. 16 minus 80, that is coming as minus 60, minus 64 meter. Okay, so this is the one, minus because upward and the bridge is downward. From reference point it is down. Okay, reference is standing is upward, that height is coming downward. That is why the height has come as minus. So answer will be 64 meter. Next, a very long conducting wire is bent in a semicircular shape from A to B as shown. Okay, the magnetic field at point B is steady state current configuration. Fine. So basically it's a Weier's law. This is the whole wire for you. So you have a wire, this is a wire. The long wire is now bent like this and bent like that. So you have got 3 portions. This portion say 1, this portion say 2, and this portion says 3. So there is a current going like this, then going like this, and going like this. So for this current, you see, when I try to put it out, it is coming upward for this current and for this current, right? Getting my point? So what happens is fields of these two are adding, whereas field of this is subtracting, and this point P. Okay, so when you go over here, see what is happening. So what will happen is, because of this straight line, this is straight line, but this is a bend. Am I right? This is a bend. So because of bend here, the magnetic field because of a circular ring will come in picture in formula, and a straight line will come in formula. So for 1, what is going to be there? For 1 we will have mu 0 I, for first section, mu 0 I by 4 pi times r, r is the distance, right? Similarly, for third will be mu 0 I by 4 pi r, this one, and each one will be having field as upward, right? Whereas because of 2, for 2, it is mu 0 I by 4r. There is no pi over here for the circular, okay? And this field is now opposite, is going downward. So total field, will be 1 plus 2 plus 3. So that is mu 0 I by 4 pi r minus mu 0 I by 4 pi r plus mu 0 I by 4r will be, how much it is? Directions are opposite, so this I have taken opposite, then this is the positive, right? So this is mu 0 I by 2 pi r plus mu 0 I by 4r, okay? So what we do is, seeing the way it wants to take the mu 0 I by 4r common. So take mu 0 I by 4r common. So it will be mu 0 I by 4r. So it will become 4r, okay? Become 2 by pi minus 2 by pi plus 1. This is mu 0 I by 4r 1 minus 2 by pi. Mu 0 I by 4r 1 minus 2 by pi. So this is the correct answer. Okay, done. Next, logic gates. So for the following logic circuit, the truth table is this or this or this or that. Okay, easiest way is we can do multiple ways of that. We can think of a signal. This is an AND gate and this is an invert gates, right? We can think of putting a, we can modify each by one, verify one by one, or else the best way is, how is the function written? Why we can write is, this is A invert, B invert, and this is a NAND gate. So AND NAND, right? This is what is the logic. So that can be written as A plus B. Okay, this can be, so A plus B truth table means any one is there, then it should be 1. Any 1 is there, then it should be 1. 0 and 1, no, this is not allowed. Both 0, no. Both 0, 0, 0, 0, 0, 1, no. 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0. 0, 0, 1, 1, 1, 0. Yeah, this is the one. This is the one for you. See, both 0, then it should be 0 like an OR gate. Any one is 1, then output is 1. So your answer is 1. Okay, next. Calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is 0.15. Okay, so what you are trying to say is, you have a body, you have a car, and there is some material over here. Okay, so if the car is moving in this direction, the frictional force is going to work in this direction, right? The whole thing has got mass mg working like this. Okay, this is the mg is the weight which is working downwards, on which the friction F will depend, and the acceleration in this direction will be, force will be ma, right? So for this to not move upward or downward, this should be equal to the static friction. So ma must be equal to mu times r. But what is r here? Mg. So mu times mg must be equal to ma. Mm gone. So a must be mu times g. What is mu given to you? Okay, the coefficient of static friction, calculate the maximum acceleration, is 0.15. So mu is given to you as 0.15 and static friction is given to, g is given to you as 10. So this comes out to 1.5 into 10. 0.15 into 10, that is 1.5. Okay, so actually it is coming as a is equal to mu times g. So mu is 0.15 and g is 10, so it comes out to 1.5 meter per second square. Yes, this is the one. 2. Okay, next. The net impedance of the circuit as shown in this figure. Okay, you have been given L is equal to 50 by pi millihenry. Okay, C is given to you 10 raised to 3 by pi microfarad, and R is given to you is 10 ohms. Okay, this is the supply. Supply is 220 volt 50 hertz, right? And what we are being asked is impedance. Total impedance. So how do we calculate? You know, from here F is coming as 50. So omega will be 2 pi F, that is 2 pi into 50 is 100 pi. Okay, now omega is known to you. So for L we will calculate XL is omega times L, that is 100 pi into L is 50 by pi into 10 raised to minus 3. It's given as milli. Okay, so how much it is? 155 ohms. 5 ohms, right? This is your XL. XL has come as, XL is coming to you is 5,000 into 10 raised to 3. So 5 ohms, right? Similarly XC. XC is 1 by omega C. So that is 1 by 1 by 100 pi into what is C? C is 10 raised to 3. 10 raised to 3 by pi, it is over here. 10 raised to 3 by pi omega C. So what do you get now? Pi gone, 10 raised to 3 by 100, 10 ohms. So XC is 10 ohms, right? And R is anyway 10. So what is the impedance Z? Z is XC minus XL square plus R square under root. So you put it over here, you will get it 10 minus 5 square plus 10 square. R is 10, right? So this is 5 square plus 10 square, right? 100, this is under root of how much? 25. R is 10, right? No, R is 10. So 10 minus 5 square plus 10 square, 5 square plus 10 square, 100 and 125. 100 and 125, so 10, okay. Yeah, so this is the one. 125 under root. This is under root of 125. It is 25 into 5. So 5 root 5. This is the answer 2. Okay. 3. Finally, a nice good question. In the figure shown here, what is the equivalent focal length of the combination of lenses? Assume that all lenses are thin lens. What is trying to tell you is use the thin lens formula. What is the thin lens formula? 1 by f is mu minus 1, 1 by r1 minus 1 by r2. This is your thin lens formula. Now you have got 3 lenses over here. Plano-convex 1, convex and plano-convex and then concavo plane. So there are 3 lenses over here. So we can say 1 by f is 1 by f1 plus 1 by f2 plus 1 by f3. f1 is plano to 1.5, f2 is this length and f3 is this length, right? So find out f1. Okay, for first 1 by f1 will be 1 to 1.6, so 1.6 minus 1, 1 by r1 is infinity, right? And r2 is positive, minus 1 by r2 is 20, each one of them are 20, so it is coming as 1.6 minus 1, 0.6 by 20 with a minus. 1 by f1 is this. Similarly, 1 by f2 is 1.5 minus 1. And this is positive 1 by 20 minus this is negative minus 1 by minus 20. So that will be 0.5 by 2 by 20. 1 by 10, 0.5 by 10. Okay, 1 by 20 plus 1 by 20 is 1 by 10. So 1 by f2 is this, and similarly f3, 1 by f3, where shall we calculate? 1 by f3 is 1.6 minus 1, and now 1 by minus 20 minus 1 by infinity. Okay, so how much is this coming? 0.6 by 20 with a minus sign. Now you got all. So this will be 1 by f1 is 0.6 by 20 with a minus sign. This is 0.5 by 10 plus minus 0.6 by 20. So you can say minus 0.6 by 10 plus 0.5 by 10 is 1 by f, and it is coming to, okay, 100 of a minus sign. Yeah, minus 6 minus 0.1 by 10, that is 10 by 0.1, 100 minus 100. So this is the answer. Okay, next. Okay, an electric dipole is placed as shown in the figure. Okay, 3 centimeter from center, it is 0.5 centimeters. The electric potential in 10.2 volts, in the multiples of 10.2 volts, that you should remember. At point P, due to dipole, Okay. Everything in centimeters, so you have to take k as this 1 by 4 pi epsilon, right? Fine. So this is an axial position. This point potential due to this, and the same point potential due to this, right? So what it will be? K into Q by R is the potential. So the total potential V will be K into Q, whatever is the Q, right? K into Q. Now what is the R for this? This is 5 minus 3, 2. So 2 into 10 raised to minus 2. KQ by R, right? And this will be plus minus KQ by R. Now R is 5 plus 3, 8. 8 into 10 raised to minus 2. Okay. So take the KQ into 10 raised to 2 common. So this is 1 by 2 minus 1 by 8. Okay. That is KQ 6 by 8. 6 by 8 is 3 by 4. 3 by 4 KQ with a positive sign. 3 by 8, sorry. 3 by 8 KQ. Yeah, this is the one, right? 3 by 8 KQ. The positive sign, right? Okay, 47. 48. A bullet from a gun is fired at on a rectangular wooden block with velocity u. When bullet travels 24 centimeter through the block along its length horizontally, velocity of the bullet becomes 1 by u by 3. Okay. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. The total length of the block is fine, fantastic. Okay. So you have a block. This is the total length of the block T. What is happening is when the bullet travels through here, say this is 24 centimeter, then here the velocity is u by 3, where there the velocity is u, and here it becomes 0, v equal to 0. This part we do not know, so we will write the equation in two parts. I don't know what is the retardation of that, so take the retardation is a. In that case, v square is equal to u square minus 2as, right? That's the first part. So v square is nothing but u by 3. When it reaches to this, it becomes u by 3. U by 3 square initially is u square minus 2a, and distance traveled is 24, right? So it becomes u square minus u by 3 whole square is 2a into 24. 2a into 24. This becomes u square 8 by 9. 8 by 9 u square is 48a. 8 by 9 u square is 48 times a. Now write for the second portion. So from second portion, 0 square is equal to u by 3 whole square minus 2a into, we do not know the thickness T. We have no idea what is the thickness T. Okay. So from here, u by 3 whole square is equal to 2ta. This is number 2. Okay. So what we can do is, we are interested in finding out the value of, in terms of 24. So 2ta. This part is not known to us right now. So we go back and put in 8 by 9 u square. Now we put in this formula. Anything we can put. From here you can say u square is equal to 9 times 9 into 2ta. So put in over here u square value. Okay. So what will happen? 8 by 9 into 9 into 2ta into 2ta is equal to 48a. Right? A goes away. So you get t equal to 48 into 9 by 8 into 9 into 2. Right? 9 9 gone. 6 2 3. So now this distance is 3. Total will be 24 plus 3, 27 centimeter wooden block. Do you have 27? Yes, we have. This is the answer. Okay, next. Two thin lenses are of same focal length f, but one is convex and another is concave. When they are placed in contact with each other, the equivalent focal length 1 by f is 1 by f1 plus 1 by f2. 1 by f minus 1 by f is equal to 0. So, equivalent focal length will be infinite. 1 by f is 0, so f is equal to infinite. It will work like a plane. 3. Okay. So the next one, wire carrying a current I, current is I, length L along x-axis, and B is given to you as 2I plus 3J minus 4K. Okay, F is what? So F is I L cross B. Okay, that is I L, it's along x-axis, so I cross 2I plus 3J minus 4K, right? That will be IL, I cross I, 2I cross I plus 3I cross J minus 4I cross K. That is IL 0 plus I cross J is K, so 3K, I cross K is minus J, so plus 4J. So F is equal to 4J plus 3K IL. So therefore mod of F will be 4 square plus 3 square under root IL. That is 5IL. 5IL. Yeah. So this completes the complete questions what we have been asked in the NEET 2023 with respect to the physics portion, right? As far as the F2 test booklet is concerned, but I am very sure all other booklets are going to have the same questions, minus 1 or 2 of the similar type. What I was trying to tell you before starting this session is that the papers in this particular case, contrary to the voices which are echoed, it is rather easy, because when I see the papers of 2022, 2021 or 20 or 19 or 18, at least the last 5 years, I find those questions much more deeper and much more calculative, whereas in this particular case, at least out of the 50, I can tell you 45 such questions are there where we are straight putting the formula and getting the answer. Okay, even the calculation part is also very, very less, except for those 4 or 5 questions. What we saw is the lens formula, then we saw about the wavelength, I mean the critical angle calculation, where it is a bit turned around. You are trying to think 2 or 3 levels, distance x covered in T1, distance 10x covered in T2, and then critical angle. So there was a second or third level of interpretation. One simple that magnetic field calculation, magnetic effect of the current, that field calculation. Then the optics that optics one, F1 plus F2 plus F3. Apart from those three, that's what I'm trying to say. 4 or 5 such questions were there, which are requiring a little bit of depth inside. Otherwise, the questions were straight on the formula, and they were much more easier. There were very less questions with respect to the time mismanagement. I mean, there were hardly any questions set over here which could have an intention of throwing out your time management thing also, because there is very little calculation and we could have done it easier. That is what is my estimation. Let's see or see at your end how it echoes at your point of view, but you might have seen it out that most of the questions are straightforward. We put it on a formula and it is coming it out. Now coming back to the second part, why people think that it was a bit tough. For that I have put an analysis over here. So this is what is this year's question paper to you. If you see it out, units and measurements have been given 2 questions, and this time all of them have come from error analysis, and they were very simple. So compared to the previous years also very simple. We expected 2 questions out of unit and measurement, they are there. Kinematics and laws of motion this time has got drastically much more number of coverage over there compared to all other years. Okay, so that could have probably made you off balance with respect to the trend. Similarly, work, energy and power, as it is, you expect 0 to 1 questions, you have 0 to 1 questions. Motion of the particles, as it is, normal coverage. Gravitation, as it is, normal coverage. Properties of matter compared to fluid, solid and all others, right? It is again normal coverage. Thermodynamics is the one which has got the least preference this time, which normally used to have a much more weightage in the earlier 5 years paper. So that could have probably given the question a somewhat off track kind of thing. Rest all, again when you say oscillations and wave, behavior of kinetic theory again has been discarded. So generally a kinetic theory of gases, thermodynamics, system of particles are taken as the heavy blocks from the class 11, and current electricity is taken as the heavier block in the class 12 side. What has happened in this paper, thermodynamics and the kinetic theory has taken a bit offside. Instead of that, kinematics has taken the main role this year in this particular NEET 2023 paper. And if you go further, you find, see, 4 plus 6 plus 3 plus 5, you see this much. The major chunk has gone to electricity. This is the major difference. When we see electrostatics, current electricity, magnetic effects of the current, and electromagnetic induction and alternating current, I mean the whole that current electricity or charge and electricity, if you say together, electrostatics, current electricity, AC currents, induction effects, these 4 things are all related to electricity. Okay, then you find it out that they have taken the biggest chunk in the whole thing out, okay, which is normally not seen. And the devices, like earlier used to have more number of questions coming from the devices, now this year it has got very less coverage. This is what you can say. So that way, if you see, the pattern has been, I mean the questions are straightforward in our analysis. The questions were straightforward. It was pure on the formula based. It was much within the time frame. It was designed in such a way that we could have solved in much within the time frame without any off balance as far as the time budget is concerned. But yes, they were little bit off track in terms of weightage and coverage, the way it used to be there in the earlier 5 or 6 years paper. This is what is our conclusion as far as the physics section of NEET 2023 is concerned. Hope you have liked it out, and at the same time it might also help you out in analyzing how the questions were there, where you went wrong, what was right, and all this and all that. Okay, this is all about the NEET 2023 physics. See you later with the other portions of chemistry and bio. Thank you. Have a good day.